Alright everybody, last video for chapter 4. This one about section 4.5 covering angle-side-angle congruence postulate and angle-angle-side congruence theorem. So, angle-side-angle is kind of like side-angle-side, but you're swapping out the sides for the angles. So, if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. What this means, an included side, again, is the side that's going to be between two angles. So if we have angle A and we have angle C, the included side is AC. It's the one that is between the two angles. So, angle A and D are congruent, AC and DF are congruent, and C and F are congruent. Since these are both two angles with a side included between them, there and there, these two triangles are congruent. That's how angle-side-angle works. And then there's a different one called angle-angle-side. Notice that the order in which they appear is different between the two. So this one says, if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So notice that in this picture, just like up here, there are two angles and a side that are congruent. The difference is where the congruent side is. In these ones, we have our two angles that are in a row with nothing between them, and then we have a side that's congruent. It happens again on this one. Notice that in this one, the side that's congruent is between the two angles, and in this one, the side that's congruent is outside of the two angles. That's the difference between angle-side-angle and angle-angle-side. So, at this point we have 4 different theorems that can be used, actually 5, to help us see whether or not shapes are congruent. We have side, 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 angle, side, HL, special to right triangles, angle, side, angle, and angle, angle, side. So with these 5, we have a lot of different ways that we can show that two triangles are congruent, but it won't always be the case. So in these 3, we're looking to see if we have enough information at all to be able to do so, and if so, which of these 5 will we use? So, for this first one, we're told that this side and this side are the same, and that this angle and this angle are the same. We don't know anything about the lines being parallel. But, one thing we can say is that since these two lines, these are opposite rays here and here, 2 pairs of them, we do have vertical angles. So we can say that this angle here is the same as this angle here. Notice that I'm using 2 marks, because 1 mark was already used up here, and we don't know if these are the same as these 2. But, look at what we have now. This changes everything now that we have these vertical angles. Because now, we have 2 angles that are congruent, and then a side that's not between them that's also congruent. We have an angle, then a side. And then we have the same angle, same side. So, this one is a perfect example of where angle, side would be used. This one here. So, here's what we know. We know that this angle matches up, we know that this angle matches up, and we know that this angle matches up. We know absolutely nothing about any of the side lengths. And, actually, we have no way of proving anything about the side lengths. So, the only thing we'd be able to say for this one would be angle, but as we discussed in the 4.3 video, there's no way for us to use that. Angle does not mean congruent triangles. So, for this one, the answer is no. Angle doesn't work. Unless your car breaks down. Anyway, C. Here we're given 2 angles that are the same, and we have the side. And remember, whenever you have a side that's shared between 2 triangles, we know that that side's going to end up being congruent between them. Reflexive property. So that changes everything, because now we have 2 angles, and the included sign between them. Remember that when that happens, we have angle, side, angle. So this one we could prove by angle, side, angle. Last problem that we have is a proof. So we're told that AD and CE are parallel, and that BD is congruent to BC. These are all already labeled into here, and we need to prove the two triangles congruent. So you can see we have a side already, and we need to find other things that are congruent. Starting with the side, though, we can say that BD is congruent to BC, because that information was given to us in the proof right there. For the second angle, I'm going to claim that ABD, this one right here, ABD, is congruent to EBC. Take a look at that. Reason being, we have vertical angles right there. And vertical angles are always congruent. And that is the vertical angles theorem. Last thing that we have is these parallel lines, and we've used this before a few times in these proofs, but when we have parallel lines, remember that parallel lines create alternate interior angles with transversals. So, here's an alternate interior angle. Here's another one. And keep in mind, we could do the same thing with this angle and this angle, but we don't need both. We only need one of them. And when we have those, actually look at this down here. Those are the ones that I used. Let me change that to reflect what I had in my notes. DAB is congruent to CEB. This is also because of alternate interior angles. It's just a different transversal. We can say that these two are the same. There's our transversal, there are the parallel lines. So DAB is congruent to CEB because of alternate interior angles theorem. So look at what we have then. We have angle, angle side, there's angle, angle side. So triangle ABD is congruent to triangle EBC by angle, angle side. And just to note, if we had, instead of these two, gone with these two being congruent, we would have been setting up angle, side, angle. But with the way the picture is right now, that's angle, angle, side. So that's these two new ones. After this, what you're going to have left to do, as far as understanding before your test, is there's a worksheet which puts all of these congruency statements together, so it's going to sort of get you ready for the mix of everything, the test review, and then you're ready for the test. So, hopefully you found these videos useful. I'll talk to all you later. Bye.